is 0, all this is 0, and y is a negative 2. Yes, this is 0. So this, when x is 0, this is 0, and when y is 2, negative 2 squared, 4 minus 4 is 0. So this point is indeed on the graph. Good. Of course I will distribute. I'm not going to use the product rule if I can distribute. So y to the fourth minus 4y squared equals x to the fourth minus 5y x squared. So then of course I'm applying the operator to both sides. So let's see what we get. On the left hand side, remember, always remember dy over dx means two things. Y is a function of x and y is a function. So we are differentiating with respect to x, and y is a function. How do I differentiate y to the fourth?
Or y cubed times dy over dx.
Awesome. Minus 8 times
Y dy dx.
awesome. The right hand side is easy. It doesn't have y in it, so it's simple. 4 x to the yes minus 10x. Perfect. We are after this, so I have to factor it out. Dy over dx, 4y cubed minus 8y equals 4x cubed minus 10x. Finally, dy over dx, this part is just algebra. How do I get dy over dx?
Divide by 4y cubed minus 8y.
Yes, so 4x cubed minus 10x over 4y cubed minus 8y. The point is given to us 0, negative 2. When x is 0 and y is negative 2. So let's plug it in and see what happens. X is 0, the numerator is 0. But I have to make sure, because if it's 0 over 0, we are in big trouble. Okay? So let's check and make sure it's not 0 over 0. If it's 0 over 3, that is 0. But if it's 0 over 0 is a problem, and if it's 5 over 0 is a big problem. Okay? So, 4 times 0 minus 10 times 0, the numerator is 0. Now the denominator, negative 8. 4 times negative 8, negative 32. Negative 8 times negative 2 is positive 16. I don't care. It's 0 over a number, so the answer is 0. So now, they want us to find the equation of the tangent line at the point 0, negative 2 that has which slope? What is the slope?
0.
Yes, exactly. So then y minus minus 2 will be y plus 2 equals 0. So the equation is this. It's a horizontal line at negative 2. So we determined the equation of the tangent line to the graph of the devil's curve at 0, negative 2. And the equation is y equals negative 2 is a horizontal line. Y equals negative 2. Any questions? Do we feel a little bit better about implicit differentiation?
Yeah. Quick question.
Yes?
You said we would be in trouble if it was 0 over 0?
Sure. Because we are not talking about limits here.
Situation?
We are not talking about limits here. This is not a limit. For this situation, 0 over 0 will be a tragedy. 5 over 0 will be a tragedy as well. Because this is not a limit. We want a slope. It means that the expression, the y, is not differentiable at that point. But if it is 0, it has to...
Hopefully we'll never come to that.
No. No. Unless it's a vertical tangent. So you may have something like this, but mainly in calculus 2. Okay? Good question. Thank you. Okay. Do we feel a little bit better about implicit differentiation? Okay, when you find more problems and you want to work on anything else on Thursday, please bring them to class from any section, anytime. So let's talk about log functions. So when we differentiated e to the x, we remember it's e to the x. When we differentiated e to a function, these are not log, the exponentials. We have e to that function times the function prime. Just a quick review of formulas. A to the x prime is a to the x times natural log a. But if we have a function, a to a function prime, it's a to that function times the function prime times also natural log a. This was a quick review of the inverse functions of the log. Okay. So we're going to start with natural log. Natural log function prime is 1 over x. Now, again, what happens if I have natural log of a function prime? Can anyone come up with an idea? What do you think about natural log of a function? Based on what you see here and what you see here, what do you think natural log of a function prime would be?
Would it be 1 over f?
And then times f prime.
Indeed, awesome. That's what it is. So natural log of a function prime would be 1 over f times f prime. Now, what happens if natural log, in other words, if log does not have base e, but it has base, a general base, like 10, 15, 100, it doesn't matter, but not e. So then we have log base a of x. Very easy to remember if you remember the change of base formula. The change of base formula says natural log x divided by natural log a. And then when I want to differentiate this is a constant. I'm differentiating that. So I have 1 over x natural log a. So very easy to remember if you remember the change of base formula. Log base a of x is a ratio of natural log x over natural log of the previous base. And now when I differentiate this, I'm using the same formula. 1 over x times natural log a. Now, what happens if I have a function here? Log base a of a function. Can anyone help with this formula? You have the difference. What do you think we have for log base a of a function?
So it would be ln of f times f prime?
So it has to be this formula combined with 1 over f, right? So 1 over f, this is 1 over f, natural log a multiplied by f prime. So all you have the exact same formula, but because it's not natural log, it's log base a. In addition, you have the natural log a. It's the same formula. These two are the same, with the exception of natural log, because here if I write natural log e, it will be 1. But here I have to write natural log a, because the base is not e. So let's look and practice these formulas. And this is in the next section, 3.6. Here it is. So we have from 2 to to 26. We are applying the given formulas that we just discovered right now. And they are combined with the chain rule and combined with everything that we've studied so far.
17.
Yes, so let's start with 17. Perfect. And this is page 13. And we are looking at 17. So you said t of z equals 2 to z times log base 2 of z. Interesting. Nice pick. I don't remember anyone picking this one. Awesome. So we want to find t prime of z. Remember, first we have to look and identify which formulas or rules apply here. So what is the first rule that we have to identify for sure?
That it's a product.
Yes. So this is number 1 and this is number 2. Awesome. So let's go back. How we differentiate 2 to z is 2 to z times, because it's not e to x prime will be e to x. But it's not e to x, it's 2 to x, or 2 to z, the same thing. What am I missing here?
The ln
Yes.
of a or I.
Exactly, awesome. Multiplied by the second function, log base 2 of z plus. I don't have enough room here, so I'm continuing underneath. So 2 to z. And now we just discussed this formula. Log base 2 of z. This will be 1 over z, but I'm missing something. If it's natural log z, it's just 1 over z, but it's base 2.
ln the log 2.
That's it. You can leave it alone. You can factor out 2 to z, there is no point. This is it. 2 to z times natural log times log base 2 of z plus 2 to z divided by z times natural log. Maybe I can condense it a little bit. Maybe 2 to z natural log 2 log base 2 of z plus 2 to z divided by z natural log 2. Do not try to simplify anything. This is it. Any questions on this one? Okay. Anything else? I would like to choose 1 myself, let's say 21. So y equals natural log of e to negative x plus x e to negative x. And then I would like to choose one from here. Okay. So, y prime equals. What is the inner? What is the outer? What is the inner? What is the outer?
The inner is inside the parentheses.
Correct.
Outer is outside.
Of course. So we have to differentiate the outer first. How do I differentiate natural log of something?
1 over.
1 over the something times the inner function prime. Let's differentiate e to negative x first. When we differentiate e to negative x, what do we get?
Negative e to the negative x.
Very good, awesome. Now here I have to be very careful. Function 1, function 2. Function 1 prime is 1 plus. So 1 times the second one plus the first one times the second one prime. But you already told me what it is, so I'm going to write it negative e to negative x. Let's stop for a moment and see if you have any questions. Is this okay? Everyone?
Yeah.
So let me just repeat. 1 over this times this one prime is negative e to negative x. But now I have to use the product rule. First function prime is 1, so I have to copy the second one. Plus, I have to copy the first and I differentiate the second one. So here's what happens. Negative an apple plus an apple, these two go away. So then the numerator is negative x e to negative x. And the denominator has a common factor. Can anyone tell us which common factor will you factor out?
E's in negative x.
Good. And let's see, I have 2 terms, I have to have 2 terms inside. Can anyone give us 2 terms inside such that this times this is this times this is that?
1 plus x.
1 plus x. And of course, this was my purpose. That's why I factored. So the simplified form has now negative 1 in front, x at the top, and x plus 1 in the denominator. Any questions? Any questions, please? Okay, so now your turn to choose something. Differentiate f and find the domain of f. Find an equation of the tangent line to the curve of the given point, at the given point, or anything else. Any preference? No preference, I will choose. I would like to choose 34. In 34, we have f of x equals the square root of 2 plus natural log x. What did we say about differentiating a square root? What is the formula for differentiating the square root? Because we have to differentiate the outer first.
Isn't it 1 over 2?
Yes, 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 yes. 1 over 2 to the square root of whatever, and then times
Is it dx over dy?
times the inner function prime. Can anyone differentiate this? And I'll put it here.
1 over x.
1 over x. That's it. So the final simplified form is this. Condensed. It cannot be simplified. This is it. Any questions?